In this chapter, we're talking about modeling distributions of data. In this specific section, we're talking about describing a location of a distribution. There are several objectives we're going to focus on today. Mainly, we're going to talk about percentiles, cumulative frequency graphs, and also talk about a standardized score or z-score. Measuring position or percentiles is one way to describe the location of a value in a distribution. It's telling what percent of observations are less than it. The pth percentile of a distribution is the value with p% of the observations less than it. You've probably heard of percentiles in the past when you would get your PSSA scores back or your Keystone exams. It would tell you what percentile you fall. So Jenny earned a score of 86 on her test. How did she perform relative to the rest of the class? So we can see Jenny's grade on this stem and leaf plot of 86. And her score was greater than 21 of the 25 observations. Means that there were 21 people below her with lower scores. And 21 divided by 25 is 84%. So Jenny is at the 84th percentile in this class's test score distribution. We can also find percentiles by using a cumulative relative frequency graph. It displays the cumulative relative frequency on each class of a frequency distribution. So if you look at the age of the first 44 presidents when they were inaugurated, we have a class width of 40 to 44, 45 to 49, and so forth. And we have the frequency, and then we have a cumulative frequency. Notice when we change the cumulative relative frequency, our total percent at the end is 100% because we've reused all of the data. We can take this cumulative relative frequency and we can transform it into a cumulative relative frequency graph. If you look at this, we can see that at age 55, it looks like we're about 50%. So if you're age 55, you're roughly older than 50% of the other presidents. Another measurement of position is trying to make a z-score. A z-score tells us how many standard deviations from the mean an observation falls and in what direction. If x is an observation from a distribution that has known mean and standard deviation, the standardized score of x is. So the z-score is found by taking your data point x, subtracting the mean, and then dividing this by the standard deviation. This is often called a z-score. So if we take Jenny's example again, she had an 86 on the test. The mean of the class was 80, and the standard deviation was 6.07. Her standardized score, 86 minus the mean, 80, and divide by the standard deviation, gives her a standardized score of 0.99. That is her standardized score. It means that she's almost one standard deviation above the mean. It's positive. That's this section so far. Tomorrow we'll talk about how we can change the center, the shape, and the spread of a distribution by adding, subtracting, multiplying, or dividing a constant.